Assalamualaikum warahmatullahi wabarakatuh. Greeting to all panels. My name is Faiz Hakimi bin Sharulizam. I'm a third year student from UiTM Shah and I would like to present my final year project, which is the improvement design of blending process. Before I start with my presentation, I would like to express my gratitude to both my supervisors, Dr. Azianti Ismail, and my co-supervisors, IR Dr. Azlina Salleh, who has been mentoring and give me a tremendous guidance during my final year project throughout the semester. So first and foremost, let's get into the project summary. Improvement design of blending process is a tweaking project on how the current use multi-stage impeller industry can be further improved to enhance the blending efficiency. Throughout the project, by identifying the problem of the current use impeller, a better impeller modification will be proposed to resolve the problem. So the subtopics that will be covered by the presentation is the first one, the literature review on blending process, impeller type, and multi-stage impellers, the problem statements, objective, scope, and limitation, the first methodology, which is the comparison between my current use impeller and 3 other alternative impeller using PubChat, the second methodology, analysis of the problem on current use multi-stage impeller, and last but not least, the expected results. Without further ado, let's carry on the presentation with the project introduction. So as we all know that many processes involved in chemical industries and blending operation is one of them. According to many authors, blending operation is widely used and commonly found in chemical and process industries. So what is blending actually? Blending is a process of homogenizing two or more fluids by blend the mixture using a mechanical agitation system. And by using mechanical agitation system, the effectiveness of the blending system are greatly dependent on the impeller configuration. As the impeller design has a huge impact on generated flow within the mixing vessel. And according to a study done by Torotua and G in 2018, lack of fundamental understanding on blending process can cause inconsistencies in blending quality. Next, let's take a look at the literature review. In 1992, Greenville has done a research on blending with pitch blade turbine, plate blade turbine, and hydrofoil impeller. And throughout the years, pitch and plate blade turbine has been widely used in mixing duty as it costs lower to manufacture. Although hydrofoil impeller costs more compared to the other impeller, it also offers more advantages. And the research has concluded that hydrofoil impeller has been proven to be the most cost-effective. In 1999, Mika has studied on 3 different multi-stage impeller flow, which is the comparison between parallel, merging, and diverging flow. And at the end of the study, the parallel flow has been proved to be the most effective outcome for overall circulation in a mixing vessel. Giroud in 2014 investigated on the potential of a pitch blade turbine multi-stage impeller and found that multi-stage impeller can be a combination of different types of impellers and does not limit to the same type of single impeller. And Giroud in 2014 also found that distance between the impeller in a multi-stage impeller, of course, must be 1 or 2 times the single impeller diameter. The further increase or decrease or more and less than 1 or 2 times the single impeller diameter will cause a problem for the mixing vessel. Next, Saravana Kumar in 2018 compared the performance between Russian turbine and pitch blade turbine and has found out that Russian turbine performance affected by the blade thickness and impeller diameter, while the pitch blade turbine is not. Giroud and Girotova in 2020 studied on the effect of axial impeller and radial impeller in a mixing process and has found that among the axial impeller and another radial impeller, hydrofoil impeller has been proven to be the most effective compared to others. And also, Giroud and Girotova also found that Radial impeller require more energy than the axial impeller to actually achieve the final blend. Asfar and Gottlieb in 2020 investigated the performance between Russian turbine, pitch blade turbine, and hydrofoil impeller. Pitch blade turbine and hydrofoil impeller are far more energy efficient than Russian turbine, since the Russian turbine is a radial impeller that required more energy to achieve final blend, relevant to the Giroud and Giroudova research in 2020. Ashwa Gottlieb also found that within the author research, that axial impeller has a better meshing performance than radial flow impellers. Next, the problem within the project, I have identified two problem statements, which is the first one is the overblending time, 30 minutes for meshing time and 1 full hour for circulation. And for the meshes to fully homogenize for 1 hour and 30 minutes, it is far too long for a blending process. The second problem statement is the inconsistencies in blending process. Since there is inconsistencies in blending quality, the lab testing is needed to evaluate the final blend. And sometimes in worst scenario, more than one lab testing is required. For your information, the company has done a tweaking once by increasing the distance between the multi-stage impeller from the position 1 to position 2. But after the tweaking itself, the problem still occurred. So, by identifying the problem statement, the objective of the project is to choose the best impeller for constructing a multi-stage impeller. The second objective is to compare which multi-stage configuration is much more effective when compared to the current used one. As you all know, as our aim in the project is to bring design improvement on blending process by eliminating the extra blending time. The scope and limitation of the project is the result for the project can only be calculated by using the simulation. During our world crisis, COVID-19 pandemic, any physical project will be disapproved, and the collected data during the industry visit is really insufficient for the project to run smoothly. The next subtopic is covered on the methodology. Within the methodology, three types of impeller has been introduced, which is the first one is the axial impeller, the second one is radial impeller, and the third one is the closed current impeller. As you all know that axial impeller is the current used impeller, and the proposed hydrofoil impeller is considered to be axial impeller. So the first methodology is the construction of the pub chart, which is the 45 degree of pitch blade turbine impeller has been made a datum, which is the scoring for the current used impeller is actually 0. So based on the pub chart scoring, the chosen design is a reverse impeller as it gives the most score compared to other two designs. The next one is the multi-stage impeller flow analysis. So the current used multi-stage impeller has used two of 45 degree pitch blade turbine and already have two configuration, as the second configuration is an attempt to improve the impellers. So here I already include the picture which is on the first configuration and the second configuration. Next is the geometrical arrangement for both first and second impeller. So it is to be noted that both impeller have the same diameter, and both impeller use the upper impeller to produce upflow and the bottom impeller to produce downflow. The first geometrical arrangement, the distance between the impeller is 0.23 the diameter of the impeller, and the distance between the upper impeller and the tank is the diameter divided by 0.63. The second geometrical arrangement, which is to improve the multi-stage impeller, the distance between impeller has been increased to 0.63 times the diameter. The distance between the upper impeller until the liquid height is diameter divided by 0.84. So first, this is the analysis of the first multi-stage impeller configuration. As the distance between impeller is too close, hence the flow discharge from the upper impeller is actually drawn in by the bottom impeller. As we can look here, it can be the complete opposite, which is the flow that discharged by the bottom impeller can also be drawn in by the upper impeller, which is in this case a merging flow has occurred. So when the flow is merging, there is only one circulation created, which is if multi-stage impeller have only one circulation loop, the outcome is the same with having single impeller embodied to the system. The second analysis, which is done for the second multi-stage impeller configuration, by increasing the distance between the two impellers, we can find that two separate circulation loops has been created. Although the objective of embodied or employment of multi-stage impeller to acquire two or more circulation loops, a dead zone is present within the mixing vessel and unmixed zone can cause the inconsistency in blending process. So the conclusion, as for the conclusion, 45-degree pitch blade turbine is undoubtedly widely used for blending duty in industry. Although the impeller itself is a good component, there are other choice of impeller that can perform better than the 45-degree pitch blade turbine. So, by choosing the right impeller as a replacement for the 45-degree push blade turbine, it can provide a huge contribution on the multi-stage impeller improvement and the blending process itself. For a multi-stage impeller to work more effectively, geometrical arrangement of the impeller must be taken seriously, as such parameters carry a significant effect or impact on the impeller generated flow. So the expected results are to satisfy all the project objective, which is it is to be expected that hydrofoil impeller is more suitable than the impeller on the current is more suitable compared to current use impeller for blending process. The second expected result is the hydrofoil multi-stage impeller with the right configuration can bring much more effectiveness for blending process. And the last but not least is the future project planning. So for future planning, the first is to design new multi-stage impeller. First, the new multi-stage impeller design will be based on the hydrofoil impeller, and then after the new multi-stage impeller has been designed, a simulation will be made and to analyze the flow output from the designed impeller. Then if from the analysis the flow output is not satisfied, another impeller will be designed and simulated, since one result will be compared to another result to find and choose which impeller has produced the best flow simulation. So after the impeller has been chosen based on the flow output, we have to assess the chosen impeller fabrication cost. Through the try and error course, best impeller in terms of flow can be found out, but not for cost effective. As we all know, cost and performance comparison between all design the impeller will be made and choose based on the balance between the performance and the cost. The third is to have a look on the industry perspective. In our industry, time and cost is a crucial factor in the industry. By solving a problem in industry is different from solving a problem within the studies. By understanding the view from industry perspective, impeller consists of the balance between the cost and the performance will be able to produce for the project. So that's all from me. Thank you.